Okay, so now in this chapter, we will introduce moments of forces. And we will see that this chapter is an introduction for next chapter because as we have discussed in the introduction of the course, for a particle, we don't have the equation sum of moments because all forces pass by one point, so they cannot create moments about this point. However, when we consider a rigid body, and we want to study its equilibrium, we will add another condition that for a rigid body to be in equilibrium, sum of moment should be zero. And in a rigid body, forces can be applied at different points, and we can have coupled moments also. So in this case, in order to be able to solve for rigid body equilibrium, we should learn first how to calculate moments of forces. Okay? So let us start with this chapter. First, what is by definition the moment of a force? The moment of a force is the tendency of this force to cause rotation about an axis. Okay? So for example, here, if you look at this figure, you are trying to rotate this system around this point. Okay? So you are putting a force that is perpendicular to this arm in order to cause rotation about point O. So here, this is the moment induced by a wrench with the force applied as shown. This force will tend to cause the nut to turn around which axis? Around the axis. So here, as you can see, you are trying to rotate about z. And in this case, the moment is perpendicular, the moment vector, okay, will be along z, while the force is perpendicular to z, and the arm also, this is called the arm, okay, which is the distance between the axis and your force is perpendicular to z. Okay, so what we can deduce here that in order to produce a moment about an axis, I should have a force component that is perpendicular to the axis and that is at a certain distance from the axis to be able to produce rotation. Now, let us see some particular cases. Okay, we will see that if a force has a line of action that passes through a point, it cannot do any rotation about any axis passing by this point. So if you look at the figure here, in this figure, the force Fx first cannot produce a moment about x, of course. Why? Because it's parallel to x. A force can never produce a moment about an axis that is parallel to it. Okay? Now, will it produce a force along y-axis? Who can tell me? Can it produce a moment about y? No, it cannot. What is the reason? Because it's passing by the axis. So if a force is passing by the axis, also it cannot produce a moment about this axis. So here in this problem, in this figure, Fx can only produce a moment about z. Why? Because first it's perpendicular to z, and second, it has a certain distance from z. Okay? And the moment it will produce will be equal to in magnitude to the force F times the distance d. Okay, now we will learn together how to determine the direction of the moment using the right hand rule. Okay, so we'll see after, but if I want to illustrate it for you like this here, you can do it in your mind. It's trying to rotate like this. Okay, so this is the direction of rotation as you can see here in the arrow. Now in the second figure, I have the force Fz. Fz is parallel to z, so of course it cannot produce a moment about z. Fz is passing by y-axis, so it cannot produce a moment about y. It will only produce a moment about x, and this moment is equal to the magnitude of Fz times distance d, and in direction like this. Okay, it's trying to rotate like this. Okay, and we will learn how to determine the direction of the moment in a while together. Now, in this third figure, does Fy produce any moment about the three axes?
No.
No, because it is parallel to Y, so no moment about Y. And it's passing by X and Z through the origin O. Okay? So in this case, Fy cannot produce any moment about any of the three axes, since it's passing by the origin of the frame O.
Doctor,
Yes?
there's something I didn't really understand.
Yes,
Can
tell
you
me.
go back please to the
Yes,
figure?
yes.
Okay. In my logic, I am applying a force that is parallel to Z. يعني I am applying force on a point on Y. I'm talking about the middle figure on
Okay.
Y. I
Yes.
am rotating the Y axis. That's how I understand it.
Yes, you are rotating Y about what? About X.
Yes.
Yes, so you are producing rotation not around Y, around X. يعني أنت you are imagining that your frame is rotating. This is what you mean.
I am imagining إنه الplane YZ
Hmm.
حيب will
مظبوط.
turn
Will turn
but
around what axis?
along X.
Huh?
Okay.
Exactly.
Okay, so
Okay.
in the first figure, for example,
In the first figure,
XY.
XY will turn around Z.
So we say it's the moment around Z. Okay,
Yes.
thank you so much.
Okay.
اوكي دكتور كأنه بالسيم سنت اوف اف زي هنقول بالميدل فيجر عم يبرموا الزي واي
مظبوط.
بالسيم سنت.
عم يبرموا هيك. Like this.
Yeah.
So they will tend to rotate like this around the x-axis. Okay. Okay. Now, what is by definition the moment of the force? The moment of force about point O or about an axis passing through O is a vector quantity since it has a specified magnitude and direction. Now the magnitude is given by F times D, where F is the magnitude of the force and D is the moment arm, which is the perpendicular distance from the axis at point O to the line of action of the force. Now, concerning the direction of the moment vector will be specified using the right-hand rule. And I will introduce now to you what is the right-hand rule and how to use it. Look at your figure here, okay? I have a force F that is trying to produce rotation about a point O. So first, to determine the moment, what I do is I draw the perpendicular from O towards the force, the perpendicular distance. This is called the moment arm. And I say that the magnitude of my moment is given by the magnitude of F times D. Now concerning the direction of my moment vector, my vector moment is always perpendicular to the plane of rotation. So as you can see here, F tends to cause circular rotation motion about O. So the moment vector by definition is perpendicular to the plane of motion, and it's if to know if it's directed up or down, we use what is called the right hand rule. So what is the method? The method is to determine the direction of the moment. You should curl the fingers of your right hand in the direction of rotation, and the thumb will point along the moment axis, which will determine the direction and sense of the moment vector. Let us try to illustrate this. Try to take your right hand now. If you take your right hand, you should put the face of your hand looking at O. Okay? So this is your four fingers like this. Okay? Put them in this way. And the face of your hand, يعني الكف تبع ايدكم, is looking towards O. Okay? When you try to curl your finger like this around the circle, your thumb will point up. So you curl your finger and you put your thumb will be upward. When you curl the four fingers, okay, and you try to do the rotation, your thumb will be up. This means that the moment vector is upward, okay? In case F was like this, for example, in case F was opposite, like this, in the opposite direction, what will happen now that when you curl your four fingers and the face of your hand is looking at O, then when you do this, your thumb will point downward. Okay, so this method will allow you to, this is called the right hand rule. It will allow you to know what is the sense of your moment vector. Did you try to do it? It is working with you?
Yes.
Yes.
Okay. Anyway, I will put for you a video. It will help you also to see how to do it. Okay. So, in general, in 2D problems, we have it's easy to know if you have a clockwise or counterclockwise rotation. In 2D problem, you don't need the right hand rule. The right hand rule in general is more needed in 3D. Okay. In 2D, you can just figure it by doing this. If you take the plane of motion, and if you look at the top view, okay, you draw F, you can see that simply F is rotating in which direction? Like this. So F is causing what? It's causing counterclockwise rotation here. Okay, so you can just represent the moment by an arrow like this. Okay, and say this is the direction of moment. So in 2D, if you want, we can just identify the sense of M as clockwise or counterclockwise. Okay, but keep in mind, however, that the moment always acts about an axis which is perpendicular to the plane containing F and T. So here we are
عم بدرس
representing the moment by an arrow like this, but in real case it's a vector, and this vector is perpendicular to the circle. Okay, and here you can see it clearly, it's perpendicular upward. So here, if I want to represent it as a vector, in this view, I will just see a point. Okay, I will just see a point which is pointing towards you, and if you just if you curl your hand, then the thumb will be perpendicular to the plane and pointing outward. Okay. Now, if a system of forces lies along the xy plane, the moments of these forces about point O will be directed along the axis. So if I have a 2D problem, all my forces are in one plane, then I can be sure that the moment will be perpendicular to this plane, because we have seen together that always a force, okay, will produce, if I have a force in xy plane, can this force produce a moment about x or y? No. Why? Because it's passing by these axes. So this force can only produce a moment about what? About z axis, okay, which is perpendicular to plane x and y. And in this case, we say that if we want to find the resultant moment, what we should do, we should sum all moment of forces about the axis, okay? And since it is a 2D problem, we can choose a positive direction. And you can say, I will consider clockwise, or here the counterclockwise moment as positive. So any moment in the counterclockwise direction will be counted as positive, and any moment in clockwise direction will be counted as negative. So the individual moments will be added in an algebraic way, assuming that the counterclockwise moments are positive. And you can use any convention you want. If you want to consider the clockwise as positive, you can. You just put near your equation this. This means that you are considering that this direction is the positive one. And based on this, you do your summation. But in general, why conventionally we take counterclockwise as positive? Because this will correspond, counterclockwise will correspond to a moment in the positive z direction, while the clockwise is a moment in the negative z. Okay? Why we are saying this? Because look, if this is x and this is y, okay, and z is pointing perpendicular to like this, yani towards you, okay. If you have a clockwise moment like this, okay, try to curl your hand, curl your right hand, your thumb will point towards negative z, okay. So if you try to put your four fingers like this and you curl them, your thumb will point in the negative z direction. While if you have a counterclockwise moment, okay, and you curl your fingers along it, along the rotation, okay, then your thumb will point towards positive z. This is why in general we consider that counterclockwise is positive while clockwise is negative. But in any problem, if you choose to change it, you can. You just put near the equation what is the positive direction you choose. Okay?
Doctor,
Yes.
I just got lost a little bit. How am I going to use the right hand rule in when we have the moment around Z?
Okay. Yeah, I will repeat. I will do a new figure. Okay, look. If you have forces like this, okay? And let's say a force is tend to rotating in this direction, okay? So let's say this is your force like this, okay? This is your force, and this is point O. This is the perpendicular, okay? What is the technique of the right hand rule? You put your four fingers parallel to the force and the face of your hand looking at the origin, okay. So if you want, your four fingers will be parallel to this line like this, all fingers are like this, if you want, they are your fingers are in one close to the other, pointing along the positive direction of the force, okay. Now if you try to turn your hand, try to do it. Try to turn your right hand. Your thumb will point towards this, towards me, or towards the screen, towards you or towards the screen.
It's pointing towards me.
Exactly. It's towards you. This means that it is in the positive z direction because z-axis, okay, z-axis is like this. It's towards you. Z-axis is towards you, and when you curl your right hand, your thumb will be directed in positive z. This is why we say if the moment is in the counterclockwise direction, then the moment vector is pointing in positive z sense, okay? While if you have a clockwise moment, try to do it with your hand now. If you have a clockwise moment and you put your four fingers along like this. So here, for example, if I want to, if you have a force, for example, here, like this, okay? If you have this force, this is my force, okay? And this is point O. So now if I put my four fingers parallel of the right hand rule, parallel to the force, okay, and looking at the face of my hand directed towards the origin, okay, how will my finger will point in which direction? It will point towards the screen,
You.
not towards me, okay. So this means that it's
Yes.
I know,
Yes,
look,
yes, I mean the screen.
okay. Anyway, I will post, I know that it's a little bit challenging. I will post a video for you showing this. So in the video, you will practice how to use the right hand rule. Okay.
Thank you, doctor. I understood.
Okay. Let us do a small example on how to determine moment of forces. So here, for example, I want us to determine moments about A, B, C, and D. And to determine the resultant moment in the second figure, to determine the resultant moment about. Let us start with the first figure. First, we need to determine the moment of force F about point A. Okay, so in order, the first step, whenever I want to find the moment of a force about a point, what I do is I draw the line of action of the force, and I draw a perpendicular from the point towards this line of action. Okay, and I say, what is the distance separating A from the force? It is equal to 1 plus 1.5. So in total, distance D from F to A is equal to 2.5 meters. And I know that the magnitude of the moment of a force about a point is equal to the magnitude of the force, which is here 800, times the distance separating the force to point A, which is 2.5. So I got that the magnitude of MA is 2000 Newton meter. I just still need to determine the direction. Okay, look, how is the force tending to rotate about A? In which direction? Like this. Okay, so imagine, you should just imagine how it's rotating the structure about A. It's trying to rotating in the clockwise direction. This is why I put near my MA, near the value, I put the sense of my moment. It's like this. Okay? Now, to calculate the moment of this force about point B, it's similar. I should find this distance, this one. Okay? The distance from B to the force is 1.5. And also the force is tending to rotate about B in the clockwise direction. So I put the clockwise arrow and I say that the magnitude is 800 times 1.5. Now, what is the moment of my force about point C? Will my force produce a moment about C? No. Why? Because if I extend the line of action of the force, this line of action is passing by C. So there is no distance between the force and point C, and therefore no possibility for producing rotation about C. Finally, to get the moment about D, I do the same procedure. I draw the perpendicular from D towards the line of action of the force. The distance is 0.5 meters. But what is different from the moment about A and B is the direction. Because look, let us imagine how F is rotating about D. It's trying to do rotation in the counterclockwise direction. So I just put an arrow here close to my answer, showing that rotation is counterclockwise, and the magnitude is 800 times 0.5. Any question on the first part? Okay, so yeah, just we'll do this one and then we stop. Determine the resultant moment about point O. So here I have several forces and I want to find the resultant moment about O. So I start to find the moment of each force, then I do the summation, okay? And as usual, I should use a positive direction. I choose to take the positive direction counterclockwise. So I look at my figure. First, the 50 Newton force is producing a moment in the counterclockwise or clockwise. It's clockwise, okay? The 50 Newton is trying to rotate like this about O in the clockwise direction. So it's a negative moment. So I put minus 50 times the distance 2. Now, for the 60 Newton force, the 60 Newton force is passing by O, so it cannot produce any moment about O, so it's 0. Now, for the two other forces, 20 Newton and 40 Newton, I will start by the 20 Newton force. The 20 Newton force is trying to rotate about O like this, okay? So it's a moment in the counterclockwise direction. So it's a positive moment. So I should multiply plus 20 times which distance? This is the line of action of the force. Okay, I should take the perpendicular distance from O towards this line. So this is the distance I should consider. This distance is equal to this one here. And this distance from the figure is 3 sine of this angle. So 3 sine 30. And finally, the final force is the 40 Newton force. This 40 Newton force is producing a clockwise moment about O. So it's a negative moment. So minus 40 times what? I should take the distance from O towards the force. The distance from O towards the force is the whole distance here, which is from here to here I have 4. I should add to 4 this distance, which is 3 cosine 30. So in total, it's minus 40 times 4 plus 3 cosine 30. When I do the summation, I get minus 334 Newton meter. This means that since I got a negative result and I consider that the counterclockwise is positive, this means that my resulting moment is in the clockwise direction. So I can remove the minus but put close to my value the actual direction, which is the clockwise direction. Okay. Any question? Sorry, I took from your time, but just to finish this exam. Any question on this? Okay, so we continue next time. Bye.
Thank you,
Doctor.
Welcome.
Thank you, doctor.
إذا فيك ترجع تبلش من هون بليز.